Hello everybody, it's Mr. Joseph. Here we are today doing a proof. And we are trying to prove that AD times BC equals AB times DE. This is not obvious that this is true. So that's what's great about this problem is it's not obvious. It's not clear how we're going to do it. But we are seeing two triangles here. And I made sure to kind of highlight that in green. That's a small triangle right there. I'm going to call that my small triangle. And the purple that is outlined, that is triangle ACB. I hope that you see that triangle as well. In math, you can say a lot more things if you make relationships between triangles. So I think the first thing that we should do here is first write what is given, and two, see if we can find two similar triangles. So here we see that angle C and angle DEA are right triangles. And our reason for that is given. This next step might seem a little extra, but I'm going to go ahead and write that angle C is congruent to angle DEA because that is the definition of a right angle. All number one did was tell us that they're both right angles, but if we are trying to prove that the green triangle, which is our small triangle, AED, is similar to our big triangle, ACB, it is important that we describe the angles within them, which one of them is these two right triangles right here. And of course, I use blue. Let's see red. Right here and right here. So it's a little extra, but we did it just to make sure that we're clear. The next thing we want to do is we want to find another angle, which is going to be angle A. I hope that you see the small green triangle and the big triangle both have A in common. So that is called the reflexive property. So we are going to say that angle DAE is congruent to angle BAC. And the reason is reflexive property. And the great thing about this is we have just shown that these two triangles are similar. So we can go ahead and say that triangle AED is similar to triangle ACB because of the angle theorem. They both have a congruent 90-degree angle and they both share A. So that is enough information to state that they are similar because of angle. So now here we are. What do we do next? And this is the part where you have to think outside the box. We see side length AD, BC, AB, DE, and we see that these are lengths on the small triangle and on the big triangle. So there's only one thing that relates both of them when we are dealing with similar triangles, and that is the fact that the sides of similar triangles are always proportional. So we are able to write that AD, if I take my length of AD and I divide that by AB, that's going to be the same as DE over BC. And that also goes back to dilations when we kind of learned this, that if triangles are similar, we should get the same scale factor. And the reason that you can write for this, and some students have trouble writing stuff here, I'm going to write CSSTP. And what this stands for is corresponding sides of similar triangles are proportional. That's all I'm saying. And if you did not know about CSSTP, you can literally write that whenever you have similar triangles, the corresponding sides are always proportional. So This is a big step here because it helps us so much. Because if we look at 5, I hope that you see that we can manipulate it in order to get what we want. Because at the end of the day, we want it to prove this right here. And I hope that you see if we take AD over AB equals DE over BC, that we can cross multiply both of these and we would get the statement that we wanted to prove. So all we say for our last step is we say that AD times BC equals AB times DE because of multiplication. So I would have left it as multiplication, but the technical reason is multiplication property of equality. So I know it appeared at first glance that this was a problem that we were not going to be able to do. Like, how can I turn this triangle and prove that statement? But here you just got to be creative and you just got to write stuff that you know and you have to try to look at relationships. And I hope that you see that this is a doable problem. Thank you very much, and I hope this helped.